welcome back to the channel. Today, we're going to talk about something that sounds straight out of a sci-fi movie. Supersonic jets. You might have heard terms like Mach 1, breaking the sound barrier, or supersonic travel, but what do they actually mean? And how do these incredible machines manage to fly faster than sound itself? Well, grab your seatbelt, because we're about to break it down in simple terms. Let's go. Alright, first things first. What exactly is a supersonic jet? In simple words, it's an aircraft that can fly faster than the speed of sound. Now you might ask, how fast is the speed of sound? Good question. At sea level, sound travels at about 1,235 kilometers per hour, or roughly 767 miles per hour. If a jet flies faster than that, it's officially supersonic. Most commercial airplanes, like the ones we take for vacations, cruise at about 900 kilometers per hour, just below the speed of sound. Supersonic jets can zoom past that speed effortlessly, some even going over 2,000 kilometers per hour. The famous Concorde passenger plane from the 1970s was one such jet. It could fly at Mach 2, which is twice the speed of sound. Now, you just heard me say Mach 2. What does Mach mean? Well, Mach is a way of expressing speed in relation to the speed of sound. Mach 1 means you're flying at the speed of sound. Mach 2 is twice the speed of sound. Mach 3 is 3 times, and so on. The term comes from Ernst Mach, an Austrian physicist who studied how objects move at different speeds, especially speeds faster than sound. Okay, here's where it gets interesting. As a jet approaches the speed of sound, something dramatic happens. The air in front of it can't move out of the way fast enough. It starts to compress, creating a buildup of air pressure. This buildup forms a shock wave, and when the jet finally pushes past the speed of sound, it creates a loud sonic boom. It's kind of like when you snap a towel really hard, the tip moves so fast it breaks the sound barrier, making a sharp crack sound. Same principle, just on a much bigger scale. Now you might wonder, if we have the technology, why don't all planes fly supersonic? Well, turns out, flying faster than sound is incredibly difficult and expensive. Here's why. First, air resistance. As you approach the speed of sound, the air pushes back harder and harder, increasing drag. It's like trying to run through a swimming pool. The faster you go, the more resistance you feel. Second, heating. At supersonic speeds, the air friction causes parts of the aircraft to get extremely hot, sometimes over 200 degrees Celsius or 400 degrees Fahrenheit. So, special heat-resistant materials are needed. Third, fuel consumption. Supersonic jets burn way more fuel than regular planes. The Concorde, for example, consumed almost twice as much fuel per passenger as a normal plane. And finally, remember that loud sonic boom? It can disturb people, animals, and even cause minor property damage. That's why many countries banned supersonic flights over land. Good question. Supersonic jets are designed differently from regular planes. They have sleek, pointed noses to cut through the air. Delta-shaped wings or smaller wings reduce drag and stay stable at high speed.